gonna, even though it's a top view, I'm gonna set up my tripod because I think it's easier. I'm gonna shoot from here to some point. Then I'm gonna move my tripod to another point and shoot this to another point. And then I'm gonna be able to shoot my tripod set my tripod up another place. Okay? Are these points important? No, I don't care where they are. I just need to get from there to there. They're called turning point. Turning point 1, turning point 2. Okay. So I set up my equipment. I look at the back sight. Sorry, I didn't use that word yet. A benchmark. Then I look at my turning point, and then I move my instrument to another location. And then I move my equipment. So how many setups do I have here? Setup 1, setup 2, setup 3. Yeah.
Typically, how big is a rod actually?
Rod is a little taller than me, 8 feet, 7 feet, 8 feet.
For a lot of these limitations.
Yes, but the rods can get extended. That's a good point. Let me just bring up the rod.
Imagine like a 200-foot rod.
This is like a mountainside.
Yeah.
The level is like one of those like oil
It's pretty hard.
towers
All I do
scale.
my first survey I ever
That's what I was envisioning.
Here's a rod.
Yeah.
Yeah. But you'll notice that there are 2 pieces, so I could actually extend it. But you have to make sure that it's locked when you extend it, because you don't want it to fluctuate. You want it to stay the same length.
Is there a level on the rod as well?
Yeah, there's a little bird's bullseye level, and I'll show it to you in a little bit. Yeah, to make sure that it's vertical. Actually, let's just talk about that now. Do you know why? Why did he ask if there's a level on the rod? Okay, so let's say Cody with a C. So if you were looking at your eye level, right?
Yeah.
Maybe here? Can you maybe see this number? Can you
Yeah.
see that number from there? 3,
Yeah.
right? Well, let's say I leaned it really forward and you're still looking level. Would you see a smaller or a larger number?
Oh, it's a large number.
A larger number,
3 again though.
but 3 more, 3 and something, right? And if I'm exaggerating, if when I held it, instead of holding it upright,
I see 7.
you still see a higher number than 3, right?
Yeah.
So the lowest number you read is when I'm really holding it correctly, vertical, right? So typically, people don't use a rod level. I would just move it like this, and Cody would keep looking through his instrument, and he would get the smallest number, and then he knows that's when it's vertical. But to make it easy for us, we went out and bought a little rod level for you. Okay? But again, it's called differential leveling. It doesn't matter what numbers are on here, as long as the numbers don't move on here, right? Because if I started at 20 on the bottom and went up to 28, it wouldn't matter if I'm reading 20 to 28, because you're still reading the same numbers when I move from one place to another, and it's the difference in it, differential leveling. So now, and we'll look at this in a little bit, because we need to know how to read it. If we look at, we're going from point A to point B, right? Because our first point, we need to know what the elevation is. So this is actually called, when you do a rod reading going back, it's called a back sight. And then it's called a foresight.
So the back sight is the one that has the benchmark.
That's right, the back sight is where you're coming from. In this case, so let's look at this one. For setup 1, where's the back sight? What am I looking at? The benchmark. So here's my back sight for setup 1. And then what's this here? The foresight for setup 1. And as long as I know this elevation, I can calculate this elevation. Then I move my equipment to setup number 2, and what am I looking at now when I look at turning point?
Backside.
This is backside of what?
Set up.
Turning of second. And this is foresight of the second setup. Right, so setup number 2, this is what this 2 represents. It's the setup number. And then I move my equipment again and I shoot the TP2, and what would that be? Backside 3. And then foresight 3. And again, this represents my setup number. So your question was, you're always shooting back to the backside. That's true, but initially. But then I'm not shooting to the back to the benchmark anymore.
Right.
But once, if I know the benchmark elevation, I can calculate this, so I know the elevation of TP1 now. And once I have that, I can take a backside and then the foresight. And then I'm basically transferring the elevation, and I finally find out what the actual elevation is of this point. And then I put a little temporary marker so I can shoot off of that from then on.
So the longer your distance is, a much higher your chance of,
Correct,
okay,
that's right.
you're transferring error from one point to the next point.
Yeah, and that's when we have to distribute error. Mark, did you ask about distributing error before?
Oh, I was thinking just the, I can't remember what it was.
Okay, but in this case, we would have to distribute error. Now, because we're dealing with measurements all the time, we need to make sure that we're checking ourselves, right? If I start at the benchmark and I make a mistake somewhere here in setup 2, this value is going to be wrong. But I don't know that I made a mistake. So in surveying, we always go back to the point you know the elevation of. So it looks like we only had to do 3 setups to get from benchmark to this point, but we actually do 4 more setups, 3 more setups, setup 5, setup 4, setup 5, and setup 6 to go back to the benchmark, hoping that we get the same elevation that we started with. We're closing our loop so we could actually check ourselves. If we don't do that, we don't know if we made a mistake. The only way to know whether you made a mistake is if you start and end at a point of known elevation. And we don't have to go back to the point we came to. We could keep going and go to the other side, the other benchmark, as long as we're starting and ending at a benchmark to check our work. Everybody okay? What questions do you have? Okay, so now let's take a look at this. We said we could calculate the elevation, and we can do it in one step, but actually in surveying you do it in 2 different steps. So you take the elevation of the benchmark and you add to it the backside, and that gives you a value. So let's take a look at this. I'm taking the elevation of the benchmark and I'm adding it to the rod reading, which is the backside. Isn't this distance the same as the distance the level eyepiece is to the data? This is called the height of instrument. Probably the term height of instrument isn't really that good, because the height of instrument, you think, oh, it's 5 feet off the ground, that's the height. And sometimes the height of instrument is actually its distance above the ground. But in this case, the height of it, and I'll tell you again when we use the height of instrument, it's something different. Oh, actually, the trigonometric leveling we did. Go to,
The rod height.
it's not the rod height, it's the height of the instrument, which would be the level. Does anybody see where the trigonometric leveling is?
Page 24.
Oh, great.
Page 24.
24? Page 24. So on page 24, the height of instrument is really the height of the instrument from the ground. So it's kind of weird because they're using the word height of instrument, the term height of instrument, to really mean two things. Sometimes it's really the height of the instrument from the ground, and sometimes the height of instrument goes all the way to the datum. There won't be confusion because we'll always have a picture with it. So in this particular case, the height of instrument is really the elevation that the level is from the datum. So the height of instrument, the first equation is you calculate what the height of instrument is, and it's equal to the elevation that you know plus the backside. Zeke, you have a
Oh.
question?
I was just wondering why. Wouldn't it make much more sense to call it level to datum? Right, I mean,
Yeah,
it's,
I
okay,
agree.
okay,
So what is the second equation then? If we're trying to find the elevation of point A, and we say it's equal to the height of instrument, and then what do I do? Subtract the foresight, right? Don't I subtract the foresight? Right? So, look up here, I take the elevation, I add the backside to it, and I get the height of instrument. Then I take the height of instrument and subtract the foresight, and I get the elevation of point B. I'm sorry, yes, I'm sorry. You're right, I'm sorry, B. It's the elevation of B. So let's look at some calculations and play with it.